Hello, everyone, and welcome to the Custom Actions, a Developer's Perspective webinar. Thank you for being with us today. My name is Cristina Constantinescu. I lead marketing initiatives here at Advanced Installer, and today I'm going to be your host and moderator. In this session, my colleague Bogdan Mitrache will walk us through custom actions from a developer's perspective. A little housekeeping before we get started, though. First, questions. You are welcome to submit your questions at any time during this webinar, and for that, please use the Q&A pane of your Zoom window control panel. We have some of our technical support team members joining us today, and they will try to address your inquiries during the presentation. We will go through all of them again with Bogdan at the end of the presentation. Secondly, this is a live webinar and we are recording it, so we will upload it on YouTube channel and send you the link within the next 24 hours. So that being said, I would like to introduce our presenter, Bogdan Mitrache, Product Manager at Advanced Installer. So Bogdan, you are in charge.
Thank you, Christina. Hi, everyone. Thank you for joining us today. Okay, let me share my screen. One moment. Hi, everyone. For today, we have a very busy agenda. I'm trying to keep it as short as possible. We're going to cover a classic and crucial Windows installer topic, custom actions. And we must admit, without custom action, building MSI wouldn't be that fun. Take my word on it. Today, I will try to go over the key elements important for any developer building an MSI with custom action. Many of these topics might be very familiar if you're doing packaging all day long. For example, if you're an IT pro working on enterprise deployment, but if you're a developer that spends 99% of his time working on your application and just occasionally fiddling with the installer package, stay tuned. I have some cool stuff and it will be very useful for you while you're starting to build your installers. Let's get started with what I consider to be the most important topic for today, besides the US elections, of course. So this is the installation script. To better understand how the installation script and what it is affects our deployment, let's take a closer look inside an MSI. I'll show you an example in just a second. The MSI package is just a normal database. When you launch an MSI installer, actually the Windows installer service is just reading the tables from your MSI, and it performs the installation based on the configurations it reads from those tables. So you're not actually executing an MSI. Windows installer is a declarative programming language. So when you are building an MSI package, you don't actually instruct the operating system how to copy the files or create a registry or do anything that's done natively by the Windows by the MSI tables. What you do inside an MSI is that you only specify what files or registry you want to be created on end user machine in the respective tables. So you declare the files in the files table, you declare the registry to be created in the registry table, and so on. You will see the tables list is quite long. So these resources are the data that you will include in your MSI database, and this is where Advanced Installer and other tools help you to easily build an MSI. You don't have to manually manage each table of your package. When the MSI is installed, the Windows installer service consumes the resources using standard actions, like the ones called installed files, write registry files, or remove existing products, standard action that you see highlighted in my slide. These actions are the same for every Windows machines, so you don't need to write any code that instructs the OS on how to install a file or a registry. This is why we actually call them standard actions and not custom actions. Custom actions are the ones for which you actually write the code and instruct the code what to do at every step. So let me give you a quick example on how an MSI looks. So if you open an MSI with Orca, which is a free tool from the Windows SDK, you can find all the tables from that MSI. And here we're looking at the install UI sequence table and install execute sequence table. These are the tables that refer to the stages executed, the standard and custom actions that get executed during the installation. The standard actions, you'll find them present in the tables no matter what tool you're using to build your MSI, even if you're building the MSI manually with Orca, but in that case you need to manually add them in the tables. Custom actions differ depending on the tool. For example, with Advanced Installer, we have a lot of custom action that start with the name AI, and we add these automatically depending on configurations you do in your project UI to make the user experience more streamlined. So we use custom actions that set the default install location or enable logging and or detect different UI capabilities of the operating system and so on. Okay, and all these actions get executed in the order specified here in the sequence column. The same for install execute sequence. You'll see that with executing actions from the execute sequence, things are a little bit different because basically here we pass through times to the list, to some of the list of actions from here. But we'll get back to this a little bit later. In the user interface sequence table, only immediate custom actions can be used. So it can contains a list of standard actions starting with begin and ending with execute action. You see them depicted on my slide here. Execute action is the one that triggers the execute sequence. So at the end of the installation process, the installer returns from the execute sequence in the UI sequence. It does that in order to execute actions that might be specified after this execute action sequence. I'll show you a detail of how these steps are outlined during take place during an MSI installation in 1 minute. The execute sequence contains a list of standard actions that start with begin and ends with install finalized. For example, if you're running an MSI silently from the command line, only the actions from the install execute sequence take place. So anything that is scheduled in the UI sequence will not get executed. But we're talking about scheduling a little bit later. In the sequence that starts with begin and ends with remove existing products from the execute sequence, only immediate actions can be used. The sequence that starts from install initialize onward and ends with install finalize will be gone through twice, as I said. So the first time Windows installer goes through this list from install initialize to install finalize and creates the script. The second time, based on the installation script, the installer executes all the action contained by the package, but only if the conditions were true when the script was built that was in the first run at the immediate execution. And when we execute the script, that's basically when actually all the changes take place on the machine. Up until that point, the installer isn't modifying anything on the machine, it's just prepping the installation with additional configuration, like setting a default installation path, customizing different files, but all those take place in the memory of the installation process. Nothing has been laid out on the system at the moment. So when the second execution takes place of the script, that's when changes start taking place on the machine. And the actual execution of the script takes place in a separate process. And we'll see how this separate process affects the entire installation process and how you work with custom actions. So when the installation script execution is done, the installer returns to the user interface sequence in its respective process in order to display the exit dialog, the last dialog that is in the case when you're running with full UI. And execute maybe any other custom actions that you have placed after the execute action, standard action. Or if you're triggering any actions using, as I'll show you later. Okay, so let me show you how the MSI here that I've opened goes through these phases. Okay, so let's close this one. And basically, this is an older version, I think version 7.0 of Advanced Installer. It will install side by side. So it doesn't touch my newer versions. So what you're seeing here, now we're actually loading steps from the UI sequence table. Okay, so let me open that one more time for you. So you can see it. So we're back in the install UI sequence table. Ordering. And here you can actually see the dialogues listed: prepare dialog, welcome dialog, and so on. Some of the standard dialogues listed here. So as long as I'm stepping to these dialogues, you should be aware that any actions that you want to schedule during these dialogues must be either triggered with a button or published event from from the respective dialog, or be scheduled in the UI sequence to take place. And as I said, none of the immediate actions should change the system. The moment I press install, execute action is executed. It's going to elevate, and now it's going to install execute sequence. And here, again, following the sequence, the order from the sequence column, all the standard actions and custom actions are executed for me. So it has created the script, and now it's trying to copy the files, create registry, create file type association. All these operations take place in the deferred execution of the script, and any other deferred custom action that we might have configured. And now when we are back into this dialog, basically the script execution that is highlighted here, step number 2 has finalized. So it has gone 2 times to install initialize, from install initialize to install finalize. And now it's going back to execute action, because it's back in the UI sequence of our table, and it's in the initial client process that launched the installation. And now, for example, I have a published event here set that is launching advanced installer using a custom action. So simple launch file custom action. And this is not a custom action that is sequenced to be executed automatically, but it's mapped to a published event on a button. And you can find those in the control event table. And let's have a look right here on the X dialog. We have an do action published event that it's launching my app. Okay, and I'm going to disable this because I already have 2 instances of advanced installer running so far. So this is kind of what happens, an example of how you can map the installation process to the UI and execute sequence tables. Now that we've seen what a script is, let's take a closer look at 2 of the most important custom action types that we've already mentioned actually. So these are immediate and deferred custom actions. And they can be used anywhere in the installation script, in the install UI sequence, and in the execute sequence. But for the second one, there is a phase where immediate actions can no longer be used. This happens when the installation script is triggered. So in the second execution between install initialize and install finalize. For the code of an immediate custom action, you should never ever modify the target machine, since those changes cannot be rolled back in case the installation fails. So this doesn't mean that you cannot use an immediate custom actions to modify. I'm just giving this message here as a warning and recommendation not to do that from an immediate custom action. The purpose of an immediate custom action is to help you as a developer to control the installer experience and gather data that will be passed to a default custom action if that is necessary. So for example, you can use an immediate custom action to set a default location dynamically. Note that setting the install location affects only the installation process and not the resources from the machine, because you're just changing a variable. You're saying, hey, app_dir, which is our property that sets the install location, now should have this value instead of the old value that it had so far. But you're just setting a variable in your installation process. With this immediate custom action, you're not actually affecting any resources from the machine. So let's say you are installing, for example, an add-in for one of your enterprise tools, and that add-in must be installed in the main install directory of your main application. But you don't know which folder that is, because it can be on a different drive letter, it can depend on the operating system and so on. So you need to dynamically detect that path. So you have an immediate custom action that searches for the main exe and retrieves the folder where that exe finds and sets that folder as the default value in the app.dir property of your new MSI. And as I said, this is just an example, a simple example of an immediate custom action from the many that we use today, like detecting if you have enough space on the machine, or having a launch condition, or controlling some UI elements from the dialog. It all depends on what you have. Maybe you can even retrieve content that you display in the dialog. I've seen customers that display dynamic content served from their servers depending on which machine the installer runs when it runs with full UI. Now let's take a closer look at deferred actions. These ones run only during the installation script execution. So that is in stage 2 that you will see highlighted with blue on my screen. And the deferred actions should be the only ones that make changes to the local machine. Why this is recommended? Because each defer action can and should have a rollback action defined, so that the changes it makes can be undone if the setup fails or it is cancelled. And I'm going to show you how that happens in 1 minute. So I have here an example of a C# custom action. I'll go over details how I created that in a few minutes. But now let's just focus on what the custom action does. So I have a deferred custom action that simply copies the log file of our installation on my C drive. And I've instructed this custom action to actually fail. Even after the copy takes place successfully, it will return a failure instead of a success. The reason I'm doing this is because I want to trigger a rollback custom action for this. And the rollback custom action, the purpose of any rollback custom action that you design is to clean up any change, to revert any changes that your deferred custom action has done. So in my case, I'm copying a file. My rollback custom action should delete a file. If I was just modifying the contents of a file that was already present on the machine, I should have created a backup before I modified it, and my rollback custom action should have simply reinstated that backup and use it to replace the file that I modified, and so on. You can imagine you basically recreating an undo functionality with your rollback custom action. Okay, so when I'm building this Visual Studio project, it's going to spit out a DLL at this path here in my user profile. And you go into an advanced installer project here. I'm just creating an advanced installer project, architect simple MSI project. I actually have one created right here. And you go into custom actions page. So we have here quite a lot of pages in advanced installer. So the list is quite long. You can use this filter to just hide some of them, or you can simply use the search to search for anything you want in your project. So now we're here in custom actions page, and you'll find this view to add basically a list of our predefined custom actions. And if you already know what you're doing, you can just go on and pick one. If not, you say, hey, I have a DLL custom action. So let's start with DLL. Help me execute one. You have a few options to execute: a standard DLL, a native DLL. This is a topic for another webinar, the difference between this type of DLLs. But if you're building a custom actions using this, the way I'm presenting here and is documented on our website, you will need a native DLL. And the difference between installed and attached DLL is the following. If you're specifying an installed native DLL, it means that the custom action can be only executed after the files from your package get installed. So you are restricted to the stage at which you can schedule your custom action. Basically, you can add it only after add resources group here that you see highlighted in our list of actions. But if you add it as an attached custom action, in that case, Advanced Installer injects the DLL into the binary table of your MSI, And this makes it available at any point during the installation. So even before the files have been installed on the machine, this DLL gets extracted into a temporary location and the Windows installer service can execute it as a custom action. And you have two options to add for each custom action that is available in our list. Is it to add it with sequence and without sequence. And more details about this I'm going to talk about at the end of the webinar. But for now, just know that I'm adding them with sequence. So when you're adding a custom action with sequence, you should expect to find that in the UI sequence or execute sequence tables, depending in which sequence you're adding them. So in my case, you see the sequences are highlighted here: install execution stage and wizard dialog stage. We've tweaked a little bit with the names to make it easier. Basically, we're hiding a little bit of the details because developers don't have that much experience with Windows installer compared to IT professionals. So we've noticed that too much detail is confusing them. So we've added a native an attached custom action. We actually have them here already configured. So I have my deferred custom action, which is basically pointing to the source of my DLL. And here we need to specify which function from the DLL. Automatically Advanced Installer detects all the function exported by the DLL, which function we want to call, and we're passing some parameters, in this case the file location of our log, which is stored in a property, a predefined Windows installer property. And another important part is the scheduling part here, where you're specifying, hey, this is a default custom action, not an immediate custom action, because this custom action is modifying the system. It should have credentials to modify this, so we're running with no impersonation, and we want to run this only during the installation. We don't want to touch uninstall maintenance phases. You can also use the condition editor to specify your own custom condition, and you have a wizard here that allows you to helps you to build the conditions. Basically, you can specify the execution to be conditioned by a file installation or by any other or by a feature and so on. Okay, so we have this custom action that is copying the file. And now what you see strange is that I also have the rollback custom action. And if you're looking here, you would say, hey, you showed me that the orders in the tables is based on the number of the sequence. So you are expecting that the sequence number is ordered from top down, and the list is executed top down, just as you see. And in most of the cases, this is how it happens, but rollback custom actions are an exceptions. And with our rollback custom action, as we've seen, we've selected the same DLL, only we've changed the function because we want to execute the rollback function. And what we've done, the most important change here is that we've scheduled it to run during installation rollback. So the installation rollback is actually a different script, separate from the installation script that I explained to you how it creates. And this script contains only the actions that get executed during the rollback. And the reason that we added it here is because when an installation fails, for example, in our case, this installation is configured to fail when it executes the custom action deferred. And when the installation failed, the rollback mechanism from Windows installer starts executing rollback actions back only from this custom action backwards. So it doesn't execute any rollback actions scheduled further on, because it assumes that the rollback actions should be executed only for the deferred actions that have taken place so far. So any actions that have been executed before my custom action, for example, if you look here, if you click on the move button, you'll find here that you have like this arrow that allows you to expand, and here you see actually all the standard actions from the package. So it allows you to even move the custom action with more details, a little bit more fine detail when configuring custom action, but it also allows you to see what other changes are taking place before your custom action is getting executed. So now it's going to start executing back my rollback actions. And let's see this in action right now. So I have log enabled here, so you can see the log being generated. So let's start building the MSI. And It's executing my installer. And we have here the C drive, just so you can see where the custom action will be, the log will be copied. And it's going to install execution stage. Remember that default custom actions can only be executed on the execute stage. So at this point, my custom action has been executed and has created the log. And you can see here. And now it has already returned an error. Okay. And now you can see the custom action rollback triggering. This is the message from my custom action, from my rollback custom action. See here the title, and you can also see the message here that I've placed in the rollback custom action. I've just said this basically is a breakpoint that allows you to easily see in which custom action you are right now. You can use this technique even to attach to your custom action and start debugging it. And basically, that's how we do it with any custom action. You add a message box on the first line, then a breakpoint after this one, and then you attach to the process and continue the execution of your installation. But now let's go back to our demo. So we have the log created, we have the custom action failed, and the rollback custom action has triggered automatically. So now when we hit OK and we leave the custom action to run, the rollback custom action completes its execution. And let me show the log. And the entire process finishes and goes back, and the cleanup is complete. So the custom action, the rollback custom action did its job perfectly. We had a failure installation, and it went back and cleaned up everything. Okay, that's perfect. So let's see if I had any more for. So now that we've seen that we should change only the system resources only using the 4 custom actions, it comes an important question. How do I send data to my default custom action? Can we use the same public MSI properties? And as you probably figured out, this is not possible because we just said that these custom actions run in a separate process. And an MSI property is only available during the immediate stage of the installation process. Because deferred custom actions run under a separate process, the only way to send data to a deferred custom action is using this special custom action data property. And now this might trick you because custom action data is not actually the name of the property. Each custom action data for a default custom action actually has a property which holds the name of your custom action. So you can, if you look deeper in the log, you'll find properties that have the name custom action deferred and so on, depending on how many deferred custom action you have that use the custom action data. So in my case here, if you look closely, I've set let me close this instance. So for my default custom action, I've set the action data field. So this is the equivalent of the custom action data property in Advanced Installer. Every time you see a custom action with the action data field, this means that here you can set the value of the custom action data property as documented by Windows Install. And you can add one property, you can add more, and you can say, you can use a separator, and or you can just add a string and so on, whatever values you want to pass to your custom action data property. So in this case, I'm setting here the property that we want to be passed to our custom action, and the way we retrieve it with the C# custom action is using the custom action property. So use the session object from our custom action. This is basically giving you access to any information from the installation process. You use it to set properties, to set to access to write in the log, and so on. And we're just retrieving this value into a string file, and then pass it to the you just process it to however we want into our installation. So if we try, for example, to access the property directly, so instead of getting it through custom action data, let's say that we make a mistake and we don't notice it and just read it as any normal property. So if you are using an immediate custom action, you just say session, name of the property between square brackets, and you would get the value of that property. And now I'm also setting my custom action to actually return success if this fails, but it shouldn't. So now let's build the custom action one more time. And basically, in this case, we should have the rollback actually triggered correctly, because we should get an error here. Windows installer should never be able to get the value of a property during a defer custom action. So now we're rebuilding the installer one more time. Let's close it. And when you hit run, advanced installer detects that any binary is included, like my DLL custom action has changed, and it rebuilds automatically. So it's going to run my installer. It's going to install execution stage, going to the second stage of executing the script. And it's already starting rolling back. You see rolling back action here. You see the message from my rollback custom action. And you see here that the custom action deferred actually got executed, but it also returned an error because we couldn't get the value as we desired. It's being a deferred custom action, we cannot access the properties from it. So automatically this triggered the rollback for our installer. So now let's let it roll back. We don't want the log. Okay, so you see, whenever you see a custom action failing, you just search for return value. So basically, if you don't know why an installation fails, just create a log and open the log and search return value tree, and it should take you to the point. Well, if you are using the show run log in advanced installer, you will see this pane that easily highlights your errors and any problems that you have with the application, with the installation. But if you're not, you just get a log from a customer or just create it from the command line, open it with Visual Studio Code or Notepad++, search for this value, and you should find the custom action failing. So here we have value, return value tree, and the name of the custom action here that failed. Also a little bit of information from our stack trace. Oh, here this is an easy one to catch because we've just seen that we're incorrectly trying to read the property, and now we're reading the property using the custom action data string that we've set, and we're leaving the custom action to return a success. So in this case, now let's build the package one more time. We should have the operation completed successfully, and we shouldn't have the rollback triggered anymore. So we're building the MSI one more time. Again, passing to the install UI sequence, starting the install execute sequence. I'm just repeating this because it's probably one of the most complicated concepts to understand for anybody else that's not building MSI packages every day. So as you see, the installation now went through successfully, no errors, everything went okay. And if we look here, we should have the log. Yes, we have the log. Basically, this log is a change expected to be performed by our program. So if everything runs okay, we find it here copied. Of course, in your installation, you're not copying logs, but maybe you're modifying a web config file or any other configuration files that you have on your machine. Okay, now. So now that I've only shown you how to work with a C# custom action, I would like to give you a little bit more options, since this is not the only way to run custom action into an installer. So basically, you can use as a source for your custom action an exe, which is not that popular these days. Very, very rarely we see this. A DLL, or a script, which can be a VB script, JavaScript, batch file, or PowerShell, mostly in the latest years. Today, we will talk a little bit about the most used ones, and those are DLLs or scripts. And I'm going to show you some script examples that I have here in my package. And I'm going to show you also how I basically disable them so I can play. So you see, I had 3 custom action here scheduled, but you didn't see anything about them taking an execution. The first reason is because only one of them is actually displaying a user interaction, a message box. And the second reason is because I actually disabled their execution during the install phase. So every time when you debug an installer and you're wondering why the custom action is running or something like that, of course, the log is the first option to see, because even in the log, you will see the condition evaluation of your custom action, and the log specifies if the condition was met or not. But of course, you should also check the project for any obvious mistake. Like in this case, if you want the custom action to be executed during the install phase, you should just tick the install option here. So we have here a PowerShell custom action. It's a simple demo custom action that writes an output into our verbose log of the MSI. We have a VB script custom action that basically allows you to get, in our case, we're just reading a property and displaying it in a message box. And we also have a C# custom action, a DLL, that we have right here. And this custom action is basically just reading a property and setting a property. This is just to show you how you read and set and get a property using C# code. You can also find this on our website documented. So, oops. Now, let's get back to our property. You see, with PowerShell and VBScript, let me show you how I added this. So you just go here and say, I want a PowerShell custom action. And you say run inline script or script file. If you already have a script file, you can just pick that. Or if you want an inline script, you just add the script and it goes here, and you can customize the script directly into our editor. You can sign the script so you can make sure that your custom action doesn't have any problem with antiviruses or any internal company policies when you're running that script, which is highly recommended. So we have here the PowerShell scripts and the VB script custom action. So let's give it a quick run to this one. I think the previous version remain installed, so advanced installer should automatically trigger its installation. This is very useful for us to easily test the application. Now it's basically installing the whole installer, and it's launching my new installation. Okay, so we're programming here, and now, okay, so I haven't enabled all the condition. As I said, so the custom action is not running. Basically, we only had the PowerShell custom action running, but we didn't have we also had a deferred immediate custom action run. You can see here return value 1, which is value 1 means success, and it also says the property has changed. It has set the value of my prop to your value, just as we have in our code. But we don't see the VB script custom action run. Let's see if we also see the PowerShell. Yeah, we also see the PowerShell script here. And you can see clearly that the VB script custom action is being skipped because the condition is false, just as I said. So every time you have a suspicion that something is not correctly executed, you can easily search for the custom action name is the same, exactly the same name that you set here. So this is the ID of the custom action. And this is very important to remember because you use it to debug MSIs by reading the log and so on. And in our case, let's just close this installation and configure the installation to execute this custom action on install to and run it one more time. So now we should have all 3 of our custom actions being executed. Okay, so it took a little while to refresh. So we have the VB PowerShell custom action being executed in the return value 1. See, actually, obviously, we execute the PowerShell script using the built-in PowerShell utility from the system. So you don't deploy anything else. You don't have any prerequisites on the machine. Just make sure that you're using, if you're relying your script on a newer version of PowerShell, you configure this as a launch condition in your installation package. So basically, go to launch conditions page, which I'm searching it because it's full of options. So you go to launch conditions page, and here you can specify whatever options, whatever software you need your applications to be installed on the machine. You can even define your custom conditions. So you need a specific version of PowerShell to be present to the machine. You need to make sure, otherwise you might end up with an installation that fails when it runs the custom action because that specific uh, tool was not found on the machine. So in this case, the property is just displaying, the message box is just displaying default installation path that is stored into app.dir property. And after we click OK, it's completing its execution. You can see it listed in the log, return value, OK. And then it's also executing our 4 custom action, the custom action immediate. So you can see all of them are executed in the order, the top-down order specified here. You can analyze the order directly into the tables. You go to table editor and you go to install UI sequence because we've added this custom action in the UI stage. See, this is the UI stage. So in the install UI sequence, you find the custom actions here that are one after another. So they have consecutive sequences in the list. These are automatically handled by advanced install. And you've also seen that I was in the custom action table. So basically, as I said, the MSI is a database. So in the custom action tables, we have all the custom actions that are part of this MSI and all the respective configurations. But it doesn't contain any information about their execution other than the type of the custom action. Its practical scheduling takes place in the UI or sequence tables, or in the control event table if it's triggered from a dialog, as I showed you before, from a button on dialog, or you can have cases where you don't find them mentioned anywhere else in the MSI tables besides the custom action table because they are executed by another custom action from your package. So I'll show you that in a few minutes. Okay. So you can generate DLLs writing C++ code, this is actually how we build all the predefined custom actions from advanced install, or using C#, which is much more popular today because the .NET is a very, very popular development technology. C++ native code is used because Windows installer was designed in an era where .NET actually probably was a toy project inside Microsoft, and no official plans were for him to be as powerful as it is today. And in C#, you need to use the deployment tools foundations from Wix toolset, or DTF for short. And to quote Rob mentioning, deployment tools foundations is a rich set of .NET class libraries and related resources that bring together the Windows development platform technologies into the .NET world. It is designed to greatly simplify deployment-related development tasks while still exposing the complete functionality and underlying technologies. The custom actions that you've seen in my demo a few minutes ago are written using the DTF libraries, and as you've seen, with just a few lines of code, I could easily interact with my installation process. I could write in the log, I could interrogate properties, set or get properties from my installer, or simply change anything from my default custom actions, like modifying a file, registry, whatever you need on the machine. When it comes to scripting, the most preferred option, mostly in enterprise environments, is the VB script. But over the last years, PowerShell has been picking up some steam. VB script still leads the battle, but I believe this is mostly because there are a lot of old examples found on the internet from an era when PowerShell was not on the radar yet. And there is no right or wrong answer when it comes to picking a custom action source, be it a script or a DLL or an exe. All of the above are supported natively by Windows installer for years, and they all will continue to be supported further on. However, there are some things that you might want to consider when choosing your next custom actions. If your next custom action should be a script or a DLL. If you are an ISV, for example, the first and the most important thing you need to consider is the potential issues your install might be facing with antivirus solutions. And this is something we've been hit with too, not because of custom actions, but due to other reasons. Over the last years, we've seen an increasing trend of false positive detections for installers that are using script-based custom actions, mostly with VB and batch files custom actions. And it can happen with PowerShell too, but but for PowerShell, we introduced the option to digitally sign your scripts, and this raises up the trust level for the scripts, and antiviruses are not so picky with it. But we've seen many cases where antivirus simply block installers because they are trying to execute a script, a VB or batch file that for them it seems suspicious, especially if you try to generate that file dynamically at runtime. Overall, our recommendation for ISV is to avoid scripts as much as possible. This also ends up leading to a better user experience for the client and fewer headaches for your support team that would need to assist a lot of customers with false positive detections or a script host not correctly being registered on the machine and so on. If you want to see more details about possible false positive detections with antiviruses, just search for this keyword on our website and you'll find a full article where we talk in depth about this issue some ISVs have. Now, when we think about script-based custom actions, the main audience that prefers scripts over DLLs is mostly represented by IT professionals that manage application packaging and deployment in enterprise environments. And here I want to highlight that this is a full-time job for entire teams of departments, and many developers that are building applications are not aware of this, and basically they are ignoring a lot of guidelines when it comes to building applications for enterprise deployment. We actually have a full document on standards, and it's basically a checklist form which you can use it to verify if your application follows all the standard recommendation when you're packaging for an enterprise client. You should make sure that you do not have default custom actions that modify the system outside of UI sequence. You should uh, prepare you should give it access to additional prerequisites outside of the package and so on. It's a complete list. I don't remember all by heart right now, but I highly recommend that every time you are building an MSI for an enterprise customer, try to search this resource. It's available on our website, or just search on other websites. Maybe we will find some hints that guide you back to us, where you'll find a full list with the recommendations that you need, because otherwise you will end up delivering an MSI which IT pros will just uh, take out and rebuild however they want to match their standards for enterprise deployment. And as I said, they prefer scripts because, and one of the reasons they imply when doing so is the transparency of DLLs, and mostly the lack of transparency. Without access to the source code, an IT pro cannot see exactly what the custom action does. If sometimes it fails, because in enterprise environments there are a lot of additional configuration on the machine that might not be tested by you when you are building a custom action, but also for security reasons. And especially if the MSI is not digitally signed. This is much rare. It mostly happens with open source software, but if you're an ISV selling a commercial solution, you should definitely sign your MSI install. The lack itself of a digital signature can increase the chances of false positive detection from antiviruses, as I said. So once again, our advice is for everybody building an MSI EXE or MSIX package to digitally sign them. But digitally signing is a separate topic that needs more details, so we'll have a dedicated webinar for this somewhere in the beginning of 2021. Now let's focus on our custom action. Another reason why IT pros prefer scripts over DLLs, especially when they build the custom actions in-house, because they have applications built by their colleagues and they need to build MSIs and with custom action for them, would be to have access to this, is that would require them to use Visual Studio to compile the source. And many IT pros don't have the knowledge of a developer of what it means to write code, compile it, debug it, and so on, as we do with Visual Studio. But also they also lack the simple licensing because they cannot invoke a reason to their manager to spend thousands of dollars on Visual Studio licenses just to build the custom actions every few days and so. And the idea would be that everyone that touches that installer needs to have a Visual Studio license, otherwise they cannot see or they cannot customize the custom action code. So they prefer lightweight editors like free editors like VS Code, Notepad++, and so on. This allows everyone from the company to easily see what's in the package, and they don't need a license for any other software to build their custom actions. With all that being said, even scripts can cause headaches for IT pros if they are not careful. The most common source of problems is with enterprise policies that prevent scripts from running. This kind of policies are usually deployed in the enterprise by the security team. So therefore, a proper communication channel and standards should be set in place between the security and application management teams to ensure smooth deployment in enterprises. As I said in the beginning, there is no right or wrong option when it comes to how you build your custom action. But careful consideration of the above factor is highly recommended to ensure a smooth ride for everyone. Now, for the last part of our webinar, I want to give you a quick overview of how a custom action is triggered. This is what I've shown you earlier with sequence and without sequence custom actions in Advanced Installer. So if you remember here, it was an option when you're adding a custom action, custom actions view, you can hit these buttons here, sequence or without sequence when you're adding the custom action. The default is with sequence. And custom action scheduling is sometimes referred as a custom action sequencing. And this shouldn't be confused with the sequencing of app v packages or MSIX lately. It just refers to how you schedule the custom action during the UI or execute sequence, or as you will see now, how you don't schedule the custom action in any of those tables. Just like all of the above topics, this one could have its own webinar, but since we only have a few minutes before we go into questions, I'll try to give you a quick overview of what you can do when it comes to scheduling your custom actions. There are multiple options to choose from. You can decide if your custom action runs only in the UI sequence or in the execute sequence, or you can add it in both of them. You can just press the shift button and you can share the custom action here. One moment. Okay, so now I have the custom action shared between both the install UI sequence and execute sequence, and you see here I have the conditions for both of those stages available. And but the most you can also specify the custom action runs synchronously or asynchronously with your installation process. But the most important option is the one that I've already mentioned, if the custom action has a sequence or not. And sequence custom actions, as I said, are the ones that may take part in the install UI sequence or execute sequence of the package. Those without sequence are the custom actions that we trigger and demand. I've already shown you in the MSI, we had a control event that launched our application at the end when we finished installation. That was a custom action without sequence. So to add one of those, you just go here, let's say, as you can see, we have a lot of custom actions here. Let's say we want to open an URL when we finish our installation. So we add here the URL, it should be example advancedinstaller.com, let's say. And now the easiest way to see that this is without sequences is because it is missing the execution stage part of your custom action. You cannot configure when it's going to be executed, uninstall, and so on, because you need an actual trigger, be it a published event or calling it from another custom action. So published event is very easily added using the dialogues tab view. You just go here and say, I want to execute this custom action when I'm going through the when I'm clicking the next button on this dialog. So I'm going to add a new published event. You see here I'm the published events area of my dialog. And I'm opening, here we have two custom actions, a detect process, which is basically this is detecting if Firefox is running on my machine. I'm going to show you its configuration in 1 minute. And the open URL custom action. Here you can set a condition. If you want this to be always executed, just leave it like this. If not, you customize the condition. And let's go back and open this custom action. And let's just say we launch advancedinstaller.com. Now it's going to open up Chrome with too many tabs on my machine, but you'll forgive me for that. Okay, we don't want to wait for the custom action to finish before proceeding. We just let it run and we continue the installation and so on. And as I said, we also have a custom action that detects the process. And this is it just takes a parameter that says, hey, I need the process name that you want to detect. This is a list of from our list of predefined custom actions. So you have here, if you search for process, you can see detect process, the process. If you're, for example, installing an add-in and you want to make sure that the application is closed before installing any additional information, or the same for services and so on. So just search in the list. We have a comprehensive list of predefined custom actions that already do. So they just need to receive the parameter and so on. And in our case, the custom action sets the AI process state property that you see here listed to the values running or stop, depending on which state it finds the service. And what I'm doing with this custom action is that I'm not triggering it from any published event. I'm just calling it from another custom action. So for example, I could call it in a loop and check for some resource that if it's being made available or not by the system. And before I do that, let me disable the script custom action so they don't interfere with our demo. So basically, the detect process custom action is going to actually be executed by the immediate DLL custom action that we've shown you here. And how I do that is right here. So basically, at this point, my immediate custom action was just setting and getting some property values just to show you how this works. And now I'm going to enable these few lines of code just to show you how I'm executing custom action. So here, this is a message box showing the value of my AI process state property. We're getting the value of the property and displaying it into our message box. And here we're calling our custom action detect process CA Unscheduled using a due action event. So the important parameter here is the name of, or the ID, how we call it, of the custom action. This must be exactly the name that we have specified here, detect process CA schedule. And this is also the name that you can find in the tables of the MSI when you're building the MSI. You can find this name in the custom action table, and you find it here in the action column. This is known as the ID of the custom action, and this is how you'll find it mentioned in the log and so on. So now let's build our code one more time to have these latest changes. And one more thing to remember is that any unscheduled custom action can only be run as immediate. So we're going to be running this in the UI sequence of our package. We don't need to go through the entire installation. We're just launching the installer one more time. Okay, it's open. Usually when you have an open installer somewhere, you get an error like this. So let's close this one. Finish. Let's try one more time. Okay, it's building. And now we're having the execution first. It's running the custom action here that you see, my immediate custom action. Let's see how this plays. So in the log file, if you look carefully, you'll see the custom action immediate name. So this is my custom action from the PowerShell, from the C# code. This is executed according to its order in the UI sequence. If we look in the sequence here, let's go in the UI sequence. We have the custom action here scheduled. Okay, And you see you have the sequence number 1104. And right after this, we have the welcome dialog. So at this point, we only have executed the custom action, the immediate custom action DLL. And this DLL itself, it's calling, let's look at the log. It's calling our detect process custom action. So you can see here, during its code, it says begin custom action 1, which is our C# custom action. During that custom action, it's setting the data setter is basically a custom action that it's setting the parameter Firefox and is passing it to our through the custom action data to our detect process custom action. And then it's actually executing the custom action itself as stated as line 66 in my code. And now we see the custom action executed. We see changes, or every time a property value takes a property change takes place, its value is listed in the log. So you can easily search for the property name in the log and debug and see its evolution along the way. And now let's close this custom action because, okay, it's telling me that it's running and I have Firefox running on my machine. And now if I click the next button, Chrome will go crazy on my machine. Yeah, and you're seeing it's eating all my CPU and everything that Chrome likes to do, and it's opening Advanced Installer. And this is done using the second unscheduled custom action that I've added, the open URL custom action, which is said, okay, open this URL. And if we look in the log, it's gone way, way over this, so I cannot. Let's close the installation better. Let me expand this log a little bit. Okay. And let's search for open URL. It's not listed there. Welcome dialog. Open URL. Let's find it here. So you see, after the immediate DLL custom action returned its value, we went back and continued to the next action from our sequence, which was the welcome dialog, scheduled immediately after the custom action. Dialog loaded, and the moment we hit the next button on the dialog, the published event got executed. And you can see the published event here listed in the control event table. You search for the dialog name here, and that's welcome. Let's go to the end. You see the next button, and it has two events on it. First is the do action event, which is executing our option, our custom action, and the second one is a new dialog event, which is just says, hey, now open my next dialog, which is folder DLG on my machine. Okay, folks. So I think this is all we had for today. As always, you can find more resources on our website, and don't forget to subscribe to our blog to stay in touch with the latest packaging news. Now it's time for some questions. Let's see what we have here. Now sharing Q&A. Let's say we have 7 questions. First, very good questions according to my colleagues. We'll have this in FAQs. Thank you, Dan. What are the advantages of using a DLL compared to an inline PowerShell? When should we use one over the other? So thank you for this question, Liam. As I said, so DLL is very recommended if you don't want to have problems with antiviruses, and as you've seen, all the details are listed here by my colleague. Let me read this out loud for everyone. So Dan gave Dan, my colleague from support, which some of you probably already talked to, gave a more detailed answer in the chat box. So for PowerShell script, I like that I have directly my screen. I can code directly. With the DLL, I need the VS project to write to build the project and get. Now There could be a problem with the execution policies of the scripts. With DLLs, you don't have these problems. When it comes to debugging code, DLLs are much easily to DLL if you have to debug if you have the source code, because you can easily attach to it from Visual Studio. And Ryan completes this with another thing he takes into account is the decision that Dan mentioned, is that the inline PowerShell is stored in the advanced installer project in base64 encoded string. So from a source control history perspective, it makes it very difficult to see the changes on the script unless you open copies of the IP each commit and visually compare them with within the interface of advanced installer. With the DLL approach, you can easily view a history of a Visual Studio project in your source code. Okay. Another question, let me, okay. I see, I think Nathan referred to the Orca. How do you get Orca? You can find the Orca tool that allows you to open MSIs in the Windows SDK. Most of you as developers already have the SDK installed. Just search for orca.msi into your SDK installation folder. And then you need to actually install that MSI to get Orca installed on the machine. So the installation of the SDK doesn't actually install Orca on your machine. One question for, actually this is not a question. Thank you, Stephen. Stephen posted the enterprise deployment best practices document that I mentioned earlier. So you can find that in the Q&A session. We'll also remember to post this on our YouTube channel, Christina. Please note this down. What is this Orca application? Dan already replied in the chat, so I'll just repeat his answer. Orca is a free tool that allows you to raw edit MSI files or just raw viewed files. It's very useful to inspect the MSI files and make some small changes, like anything that you want. The simple case is changing a property that affects the behavior of your installer. Creating installer from scratch with Orca is quite uncommon, because you basically need to start from an empty MSI and define every character from every table that you've seen. So if you go into these tables that we have here, all these tables are generated automatically in advanced installer, depending on the configuration you add into our UI. So as you've seen, I've added the published event that got executed from the next button, and it synced the control event table, the custom action table, and so on. Otherwise, if you're building Orca to do this, Nathan, you would be doing it manually every single day. So we actually have a nice exercise for every junior that joins our team. The first task that they do is to build an MSI with Orca from scratch. And the next day we show them how to do that with advanced installer, and it's a funny experience to see their face when they see they can do that in 5 minutes instead of 6 hours or so. So I see another question regarding debugging. Okay, yeah. So the table editor, which is the equivalent view of yes. Thank you, Dan. How can DLLs affect computer under Active Directory? A question from Eduardo. I'm not aware of any DLLs affecting a computer running under Active Directory, so that shouldn't be a problem. As I showed you, so let me give you an example. All the MSIs that are built with Advanced Installer contains practically some custom actions. Even if you don't see them in the custom actions view here, we have custom actions for basically any non-native Windows installer table. So for example, if you want to configure, how do you call them, XML files. For XML files, we have a nice view here in Files and Folders page that says, I want to add an XML file to my package. And it allows you to configure rules to add some properties, references, conditions, and so on. So basically for this, we use custom tables. So we've added we're defining custom tables with schemas. And to read all these tables, the Windows installer doesn't know them. It will just ignore them if we just put tables in here. So we're also actually building custom actions. So we have a lot of custom action that configure the XML, install, remove, rollback, uninstall the XML, all the standard recommendation that I made earlier. And all these custom actions are part of, you see in this case, XML config DLL. So you can see we have one DLL, my DLL, AI stack DLL. This is a very common DLL. This contains most of the predefined custom actions that we have listed here, the list. So every time you see this name in the source column, it means is a custom action from us. So there are no problems with DLLs running as a custom actions under Active Directory or even for unmanaged PCs. Okay, one question from Bo. What is the searcher's custom action for? Actually, Ryan helped me with this. The searcher stage is ideal to spot and run custom actions that run towards the beginning of the install before the system is modified. Common examples might be to search for the computer for existing data, such as if the application is installed. Let's say if you're installing a PowerPoint add-in, you want to make sure that PowerPoint is installed before installing the add-in. A file or a registry exists, and you have enough space on the machine and so on. And then use that information to populate the installer property that you use later in the process. And you can use that property to stop the installation using a launch condition or just give a message to the user, and the user should take action depending on that message. One more from Mark Lawrence. When a custom action DLL edits an XML file successfully and completes the install, but the system reports a corrupt install package when attempting to uninstall, what could be the issue? Uninstall is clean when not using a custom action to edit XML. So license reports a corrupt install package. I don't know exactly what could be the issue in this case, Mark. The best option is to create a verbose log of the installation. And if you cannot find details in the log, send it to our team over at support@advancedinstall.com. The reasons could vary a lot. And my recommendation for handling XML files is, as I've just shown you, you go to Files and Folder page, and in Files and Folders page, you just use the predefined support from Advanced Installer that says new XML file. And then you don't need to write any code to handle those. We do that automatically for you. But if you have a more custom scenario, then you'll need to rely on your own custom actions. We also have even an XML locator in the search page. So if, for example, if you want to update an XML depending on the information that you find into your existing XML file, you can use the XML search and configure the structure of the elements to search for exactly the content that you want from your XML. One more question from James. I want to package my project together with another four-party installer, with Advanced Installer. I want the four-party installer to execute before some arguments passed to this installer. How to do this? Thank you, Ryan. Ryan was very helpful today. You can use the prerequisites area and the four-party installer as a pre-install package so that it runs before your installer. You can add them. There are any command lines for the setup files. So let me show you what Ryan said here. In the prerequisites area, one more time, here, prerequisite means basically the place where you define resources that need to be installed. So as I said, Chrome is eating everything. I don't know what's going on with him. Let me close this. Too many Google Docs document. Okay, so here in the prerequisite page, we have a list of predefined prerequisites that you can install, like .NET Framework and so on. Let's close this, log2, SQL Server, and so on. And here you can find a pre-install prerequisite, a feature-based prerequisite. Basically, this is tied to one of your features from the package. So depending on which features your customers installs, you can trigger the installation of an additional four-party installer or not. You can also configure installation of Windows features, and there are also just right click here and you add a new Windows feature bundle and just specify the features that you want to be installed on your machine. Okay, let's see if we have any more questions. So I've gone through all of them. I think that's about it for today. Christina, is there anything else that I'm missing?
No, I think we went through all of them. I have to thank Stephen for mentioning the enterprise dev checklist. It's actually there. The link to the software packaging checklist is mentioned by him, and I think another question has been submitted, or yeah. You are very welcome, Nathan. Thank you. Thank you. Also, I
Yes.
am going to come back to you within the next 24 hours. That means tomorrow, with the link and the recording to the recording of this session. So thank you so much for being with us today.
Thank you. Bye bye.